Welcome to a lesson with Dr. Powell. Let's take a look at setting up a triple integral to compute a volume. This volume, or the shape that we're going to be computing the volume of, sits above the xy plane, and it's going to be a wedge from a cylinder. The cylinder is x squared plus y squared is equal to 1, because it's a circle, but then it extends up and down as a cylinder. So it's going to be a wedge cut out of at least part of it. Notice how it's 1/2. The cylinder extends over here, but we're just going to take the part that's above the xy plane here. Okay, and then the wedge is formed by this plane right here. Z is equal to negative y, so it's in the yz plane. It's just a line, but then it extends out as a plane as you go this way and that way. So it's kind of like cut into the cylinder here, and then you're also cutting it with the xy plane. Okay, so the question is, we want to come up with the volume of this wedge that's been cut out. We've got to figure out how to do that. We're going to triple integral. Now, when we do this, and of course we're going to be integrating 1 when we compute volume. So, because we just want kind of the volume piece, dx, dy, dz. All right. So what's outermost needs to be constant. So we kind of think what kind of, and then we're going to think of slices with respect to that. In my mind, let's think about cross sections, like aerial cross sections. Like if you cut it with a knife, this is a loaf of bread. Is it easier to understand cross sections that are like this? Maybe those are pretty good, or you could do flat ones like this. Those would be like part of a circle. If you do this way, it looks like they're going to be triangles. I kind of like the triangle one. So if we want to do cross sections like this, then how are we indexing these cross sections? Notice how we indexing cross sections that look like areas, kind of as we go back. So it would be like this. So we have bunches of triangles. It's important to realize how we're going to cut it up as we do this. It kind of gives a sense for what we're going to do. If we're looking at cross sections that look like triangles here, it looks like we're indexing those by x. So looks like we're going to have dx out here, and x would go from this equation. We're going from -1 to, or from -1 over here over to 1. So, okay, that's for dx. Now for y, or z and z, let's think. Well, we have this triangle now, and this triangle exists at a particular x value. Maybe we should look at that semicircle in the xy plane. So in the xy plane, the semicircle that's on the xy looks like this, from -1 to 1. And okay, and for a particular x value, we're going to be going down right here. And then what happens is you go up, and then you have a triangle. This should be a 90-degree angle right there. I'm just kind of trying to picture it going upward like that, kind of off the page. Maybe a little better to, maybe I'll make it the angle more like that. Something like that. Maybe that looks okay. So it looks something like this. So cross section going up. So the question is, should we do y or z next? Okay. Well, if we did, so in this cross piece, so let's kind of just take a look at this. We kind of should know some coordinates here, some of the ends. We know that, so this has a particular x coordinate, and this is on the x-axis where y and z are both 0. Okay, now this is actually on the line where you have, on the curve where you have x squared plus y squared is equal to 1. So if we're thinking about y, looks like y is going between 0 and whatever this y value is, which we compute. Y is equal to the negative square root of 1 minus x squared. So y will be going from here to here. And maybe we should just do that. So dy, let's think, y will be going from, and let's start from where it is down below right here, negative square root of quantity 1 minus x squared, it's heading all the way up to 0. Okay. And what is z happening to z? So then what we do is we choose a y value somewhere as we're going along this y length. So going along the x length, and then we choose this. Now, as we're going along the y, we choose a place here, and we could do a cross section in this area now, which is a straight line. And okay, so let's see what the z values are going in between right there on this line that we have for a specific y value. Notice this line happens at a specific y value and at a specific x value, and then the z is just going up from there. So the z starts in the xy plane, so it starts at 0, and it's going up to this line. Now, how is this line described? Well, we gave it before. It's in this plane, and in this plane, the z and y values are all related by this equation, z is equal to negative y. So z is going to be equal to negative y right here. So 0 up to negative y. Keep in mind that that y is actually negative itself, so double negative would be positive. So this really does represent a positive z value here, because especially since y is headed between these, from this negative value up until 0. So this would be the triple integral that we would need in order to compute this particular volume, and we'll look at that volume in the next video. Thanks for watching.